Hello, folks. Mr. Laurie here. Welcome to another of my unscripted and poorly made videos. This one is going to be about the science of barbecue. Specifically, I'm going to be focusing on carbon, the chemistry of combustion, and in the process, I'm going to make myself and my family a very tasty dinner. I have here some ribeye steaks that I bought today at Food Max, looking very good. And I got also for the first time this Korean barbecue sauce. My son is super into Korean barbecue. And if you recall, I did a previous video where I made escabeche, which is spicy pickled carrots. Well, my son is in the kitchen right now and he's taking some Napa cabbage and chili paste, fish sauce, and a few other ingredients, and he is putting together a special pickle that is a Korean specialty called kimchi. So he's making the kimchi. I'm going to make this steak, and in the meanwhile, I'm going to show you a little bit about fire and combustion. Hope you enjoy this video. So first, I'm going to take you on a little trip through my yard out to the front where we can take a look at a tree that's been growing here for as long as I've been living here. When we moved in, it was a tiny tree, and it still has these steps that I put on here so that my kids could climb on the tree when they were little. So here's this big old tree, and if you look, you can see that the tree has its roots, so it's coming out of the ground, and you'll see that the tree itself has kind of raised up the earth around it. Now, I always ask my students, I say, where did this tree come from? We've got this big old tree. It's thousands and thousands of pounds of wood and material. This is mostly made of cellulose. It's carbon, it's hydrogen, it's oxygen. But where did all this come from? All this material that's here. And a lot of times students will say something like, well, it came from the ground. But if you look at the ground itself, you don't see any signs that the tree is digging a hole or anything like that. So when you think about trees and plants, you might be thinking about something you might have learned in a life science class about photosynthesis. This idea that the green leaves, so the green parts of the plant, contain a chemical called chlorophyll. The chlorophyll that's in these leaves is in these organelles inside the cells called chloroplasts, and the chloroplasts engage in the process of photosynthesis. So what they're doing is they're taking water from the ground. The leaves are actually breathing in carbon dioxide from the air, and then they use the sunlight energy to drive this process. And the way we usually, us science teachers, the way we usually describe this process is we say, oh, these plants are making sugar. They're making glucose, C6H12O6, glorious glucose. And you think, well, sugar, plants making sugar. And you look at plants, and yeah, there are some sweet parts, some sweet smelling parts, and fruits of some trees and things like that. But a plant itself, this isn't sweet. This isn't anything that you'd think of as sugary. But the glucose is just one of the molecules that is used as a building block to make all of these other molecules. A lot of it is this cellulose stuff that kind of makes the backbone, the fiber of all of this plant material. But when we talk about photosynthesis, a lot of times we leave out a really big, key, important part. And that's that the plant is building itself. This big old plant and that tree I just showed you, and these plants over here, these giant leaves, these things they're all being built by that process of photosynthesis. And so we're taking this matter and building these plants. But back to that question of where does all this come from? A lot of times people think it comes from the ground and it's the water from the ground or something like that, and that builds the plant, and here it is. But that's missing a really key important part. Much of this plant is carbon, and the carbon doesn't come from the ground. It comes from the air. And so when we think about carbon, we're not always thinking like, you know, sky and air and this invisible stuff that's between all of us. But that's really the source of where all this carbon comes from. And so then we take these glorious plants, and we can do all kinds of stuff. We can build wooden structures, you know, even houses and things like that are made out of this wood, this super valuable building material. The trees can continue to produce fruit, and the fruit can sustain us, so that can be our food supply. And then we can also take the material that isn't so good for building and isn't so good for food, and if it's not having any other function, we can burn it, and we can take that material and return the energy back to the environment. So tonight I intend to feed my family and feed my family well, and I'm going to use this material as the energy that's going to cook the food. So in order to get these great steaks into really tasty cooked condition, I'm going to need a lot of energy to make the chemical changes in that meat so that that meat is healthy and safe and tasty to eat. My body can digest food that's already been cooked more easily. So it's almost like cooking acts to digest or break down the molecules prior or before I eat it. So this is a piece of wood. This is specifically a piece of oak. So I have some white oak and red oak, and I'm gonna use this material, and I'm going to be building a fire here shortly. And what I'm going to do is I'm going to take this material, and it's all held together in these chemical bonds. And these chemical bonds hold energy. Now remember, the plant took the sunlight energy, and it took the carbon dioxide in the water, and it built itself out of the glucose to build the cellulose to build these these mighty trees up here behind me. So they're holding the energy that was absorbed from the sun. When I take a piece of wood like this and I burn it, I'm going to then release that energy, generate all of this heat, and then I'm going to be using that heat to cook this meat. Placing these in a triangle shape inside the fire pit, allowing air to circulate in here once I get it going. Okay, so now I'm lighting the fire. So I've got this lighter that uses a little bit of friction, the activation energy, and has a little bit of fuel in it, what we call lighter fluid, mostly a chemical called butane. And getting this going in multiple points, and then I'm hoping that the oxygen will do the work. I have this wall that insulates and protects the surroundings. And as this burns, and as anything burns, it generally is releasing heat, carbon dioxide, and water. Now, I'll say this again, but almost every time anything burns, it releases carbon dioxide and water. There's always going to be a little bit of unburnt material, little bits of ash and things like that, and just pure carbon, kind of little soot, bits of black carbon. But a lot of what comes off of a fire is actually water. And some folks don't know that, but when you look down at the fire itself and you see the smoke coming off of it, well, the smoke does contain some of that ash, but a lot of that smoke is actually water. Some of this water is invisible in the form of gaseous vapor, but then as it cools, it can form clouds. So you're all familiar with when you've seen a very smoky kind of fire. That's a fire where you're actually seeing a lot more of that water in the smoke. Okay, now I'm going to open up my Korean barbecue sauce. I've never used this before. I thought I'd experiment tonight. I'm a scientist. I like to experiment. It says to marinate it for about a half hour, so I'm going to be putting this on the meat and let it sit while the fire gets ready. Fire lit right away, so I'll get to sit by the fire and enjoy that. So here comes Korean barbecue sauce. And then I'll be mixing this around to make sure it. Okay, so now you can see that the combustion reactions are going really strong. This is a very hot fire. It's releasing a bunch of energy. That energy was all trapped in the wood, the material that's burning right now. So what's happening is oxygen from the air is combining with the carbon molecules in the wood. Those carbon molecules are big, giant chains of molecules, and they're breaking apart all over the place. That breaking apart of those molecules is what's releasing this energy. Then the carbon combines with the oxygen, and that kind of ends its story. It becomes a gas called carbon dioxide. That carbon dioxide is drifting up into the air. It's generally slightly more dense than the surrounding air, but it's warm, so it rises and goes out there and mixes with the atmosphere. So what's coming out of the fire again is water, carbon dioxide. Then there may also be carbon materials left here in the fire pit or floating up as ash into the air. Now, carbon dioxide is really important. Earlier, I talked about how the plants are always breathing in carbon dioxide and they're building themselves. But it's important to know that it's not just plants that do that. Microbes do that. Algae does that. It turns out most of the carbon dioxide that's being pulled out of the air is actually pulled into the Earth's oceans by all of these algae and microbes going about their business in the seas. But all over the Earth, the forests and other plants do this too. When we're burning something like this, or when we're burning anything, all kinds of industrial processes, cars, gasoline, factories, power plants, we're burning things and we're throwing carbon dioxide up into the air. In my lifetime, the carbon dioxide in the atmosphere has increased tremendously. You might be thinking that that number then would be a very high number, but it turns out it's still only, at this point, the amount of carbon dioxide in the atmosphere is 0.04%. That is 0.04% of the atmosphere's carbon dioxide. That absolutely vital gas that allows all of the plants and all of the algae and so on to survive is still just this tiny, tiny, tiny amount of the atmosphere. Now, it turns out that in that quantity, even though it's a very tiny amount of the atmosphere, it's still incredibly powerful in how it affects the atmosphere, the gases of the earth, the ability of these gases to absorb heat. And it turns out that on this great warm day like we had today, we really appreciate the heat of our atmosphere. I'm looking around and I don't see any ice. I don't see anything frozen. I myself, I'm not freezing to death right now. And the reason why I'm not freezing is because our atmosphere is capable of trapping heat. Well, as we increase the amount of carbon dioxide in the atmosphere, we're also increasing the atmosphere's ability to hold on to heat in a very, very tiny incremental way that year after year after year, the ability of the atmosphere to hold this heat has gone up. This is what's causing global warming. It's this combination of this carbon dioxide. There's other gases like methane and others that are let up into the air and they hold on to more heat. It's hard to explain how this works, but one of the best ways to think about it is that we ourselves, we're always radiating off heat. We try to keep cool on a warm day. Our bodies, we sweat and we release heat. Our body temperatures are somewhere around 98 or 99 degrees. And that's because we are generating this heat and heat's coming off of us. Well, if we bundle up, if we wrap a blanket around ourselves, for example, that heat doesn't have an easy way of escaping. So imagine if it's a warm day and you wrap yourself in a warm blanket. That warm blanket, it might for a moment keep you cool because the blanket itself might not be warm yet. But your own body heat is going to start to warm that confined air, that trapped air that's with you. And as that happens, you're going to get warmer and warmer and warmer. We don't like to trap heat like that. It travels in the form of infrared waves, and so the invisible waves of heat bounce back and continue to heat things. And as this happens, it creates this kind of cycle of heating and reheating and reheating. And so when the planet is trying to cool, excess carbon dioxide and other gases in the atmosphere interfere with that cooling, and so the planet gets a little bit warmer. And year after year, a little bit warmer leads to things like thermal expansion of the oceans that causes sea level rise, melting of glaciers and ice caps that causes sea level rise, changes in climate, and countless other things. An interesting thing that's happening right now because of the COVID-19 shutdowns is that we, human beings, are polluting less. And because we're polluting less, there's actually less of that carbon going up. There are cleaner skies in big cities. There are oil tankers sitting off the shores of California and pretty much every country on Earth. These oil tankers are not needed because we're not driving our cars as much. We're not doing industry things as much. And that's actually having a positive effect on the environment and may actually help us fight global warming. So what's not necessarily good for keeping our economy, the engines of our economy going, is potentially helping our environment. This is one of my favorite parts of cooking. I'm now going to put the steaks onto the fire. The grill is hot and ready to go. And I will catch you another time. I hope that you're making the most of your time with your families, that you're staying safe, and I hope to see you soon.